August 23, 2023, the municipality of Güeñes in Biscay set a new temperature record, reaching 45.6 degrees Celsius. The situation in the capitals was equally suffocating, with Bilbao reaching 42.4 degrees Celsius at 5 p.m.
Extreme heat events are becoming more frequent and intense, posing serious health risks in Spain, Europe and the rest of the planet. If this trend continues, by the end of the century, Spain will become the European country with the highest number of heat-related deaths. These effects are indeed amplified in urban areas due to the lack of green spaces, dense development, and materials like concrete or asphalt that trap heat, making heat stress even more intense.
Heat health warning systems and heat plans are important because they help reduce the health risks associated with extreme heat events. The link between high temperatures and increased mortality is well documented. As climate change continues to make extreme heat events more frequent and severe, the role of data-driven systems in protecting public health becomes even more crucial, as they not only enhance short-term responses, but also support long-term planning and adaptation to create more resilient communities.
Heat stress doesn't affect everyone equally. Personal, environmental, and social factors can make some people more vulnerable to extreme heat. Elderly, children, low-income individuals, or those with limited access to cooling spaces are at higher risk.
Municipalities in the Basque Country are becoming more aware of this problem and are seeking effective ways to assess and address heat stress in urban areas. To do so, the first step is to have high-resolution temperature maps that allow for identifying areas at higher risk. It's also especially important to identify vulnerable populations and assess how exposed they are to this threat. Finally, reducing heat stress in those specific areas requires a combination of interventions. This is why having tools that inform which measure or combination of measures is most appropriate is crucial for successfully addressing this problem.
The Heat Stress Adaptation Tool, developed as part of the European Union-funded Destination Earth initiative, helps identify high-risk areas and vulnerable populations. By considering socio-economic and health determinants, it can model current and future climate conditions using data from the Climate Digital Twin, DT, and simulate the impact of various adaptation measures, including planting trees in streets and avenues, naturalization of open spaces, or adding vegetation on roofs. It can also test how the development of urban parks and community gardens in open spaces, also the use of materials that reflect solar radiation in roofs and facades can be tested, as well as the incorporation of water features in open spaces, such as fountains or lakes and large ponds, into peri-urban areas. The tool showcases how nature-based adaptation measures are particularly beneficial for addressing heat risk in urban areas, and empowers health managers, urban planners, and territorial managers to design more resilient, climate-smart urban environments and communities, ensuring they are better prepared for the challenges of a changing climate.